So finding the expected value. Score like this, you roll 2 dice and the sum is recorded. If you score a number divisible by 3, then you win $5. So what we got to do is do a little table here. So we know that the sum of 2 dice could be 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 12. If it's divisible by 3, so this one, this one, this one, and this one, then you win $5. And if it's not, then you lose $3. So that would be a loss of $3 minus $3, minus $3, minus 3, minus 3, minus 3, and minus 3. So now we've got to work out the probability of each one. So how many ways the probability of getting 2 with rolling 2 dice? Well, it can only happen one way out of 36. A 3, well, that can happen 2 ways, can't it? A 1 and a 2, or a 2 and a 1. A 4 is 3 ways. And if you remember this, 4 out of 36. 6 is 5 ways. And then 6 ways for the 7, that's the biggest. Then it goes down again, 5 over 36. 4 out of 36. 3 out of 36 for a 10. 6, 4, 4, 6, and 5, 5. And then 2 out of 36 for 11. And then obviously the 12 is 1 out of 36. And what we do now is we multiply. We multiply this by the probability. And that gives us a negative 3 out of 36. And then we do that times that, and we get a plus 10 out of 36. And then we do these two, and we get a negative 9. And we do these two next, we get a negative 12. And these two, we get a plus 25 because it's winning money. These two become a minus 18 because it's losing. And then a minus 15. And then a plus, these two is 20. So you can see the pluses are quite big numbers. Minus 9, 3 times 36. Minus 6 out of 36. And then plus a 5 out of 36. And we've got to add this all up and see what our answer is. So it's going to be over 36. So it's a negative 3 plus a 10. That's 7. Minus 9 is negative 2. Minus 12 is negative 14. Plus 25 is 11. Minus 18 is minus 7. Minus 22. Plus 22, 20 is minus 2. Minus 11, minus 17. And then plus 5 is minus 12 out of 36. So we get negative 1 over 3. So our expected value every time we score is we are going to lose negative 1/3 of $1, which is equal to about 0.33 cents or dollars. So the criteria for a binomial probability experiment is a fixed number of trials. Each trial is independent of others. That means that one trial does not affect another, and you'll see that in a minute. There are only 2 outcomes. It's either yes or no, true or false, or this or the other. The probability of each outcome remains constant from trial to trial, and that's important too. So look at this question here, example 1. Says, consider the experiment where the 3 marbles are drawn without replacement. And the important bit here is without replacement. From a bag containing 20 red and 40 blue, and the number of red marbles is recorded. So the idea of 2 outcomes, it's either going to be red or not red. And of course, is this a binomial experiment? Well, the reason is no. And the reason being that without replacement means that the probability will change. And therefore, the one that each trial is independent of the other. Because the probability changes, they're not independent. A fair-sided dice is rolled 10 times. The number of sixes is recorded, so it is two outcomes because it's either a 6 or not a 6. Therefore, the answer is yes, it is, because the probability does not change. So if we want to look at this, a 6-sided dice is rolled 10 times. So we know that n equals 10. And just suppose we want to say the probability of there being 5 6s when we roll in the n equals 10. So we know the probability of success, i.e. there being a 6, equals 1 over 6. And the probability of failure, i.e. there not being a 6, is 5 over 6. So the probability of 5 6s equals 10 choose 5 times the probability of the 6 to the power 5 and the probability of not being a 6 to the 10 minus 5. So we get 10 choose 5, 252, then times 1 over 6 to the 5 times 5 over 6 to the 5 as well, both to the 5. And the answer is, and we get 0.013, which equals 1.3%. So 1.3% chance of getting 5 6s. So the hypergeometric, we can see the conditions here. Hypergeometric, we know that total number of items is fixed, population, the sample size is a portion of the population, and the probability of success changes after each trial. Therefore, we can make this a bit smaller and look at our question here. 5 red marbles and 6 yellow marbles in a bag. If I select 8 marbles, then find the probability of selecting 4 red marbles. So I want the probability of 4 red. And I know that for 4 red to happen, I've got 5 red altogether. That's got to be 5, choose 4. I'm selecting 8 altogether, and I know 4 are red, so therefore 4 must be yellow. Out of the yellow, 6. And then divided by 6 plus 5 is 11. And I'm choosing 8 altogether. And we need to come up with a percentage for that. We get the answer 0.454, which equals 45.4%.